Hello. Today we're going to talk about distance. Distance is a concept that's as simple as figuring out how far one point is from another, or what the length a line segment might be. So let's start with the number line. It's the simplest way to calculate a distance. If we want to locate or figure out how far point E is from point F, it could be as simple a concept as literally counting the spaces between point E and point F. 1, 2, 3, 4. So E to F has a distance of 4. And we could write it like that. When you see two letters together, like this, that means there's someone's looking or asking for or communicating the distance from one point to another. Mathematically, if you want to calculate the distance, it's a subtraction situation, an absolute value. So I could literally take the -1, which is the coordinate for point E, and subtract 3 from it, which is the coordinate for point F. Put absolute value bars around them so that it will come out positive, because there's no such thing as a negative distance. And when we do this calculation right here, you get a -4, and the absolute value of -4 is +4. So whether you look at it visually, like we did here, and you're using the picture and counting the spaces, or whether you focus on it mathematically like we did here, doesn't matter. You're going to get the same distance. Now that's as simple as distance can be. Now, we're not on a number line anymore, so let's change this up. Geometrically, this is a line segment. It is the line segment called EF. And if someone wants to now know the length or the distance, the length of EF or the distance from E to F, we can't just count it straight across on a number line. Because if you look at the ordered pairs for E and F, you can tell on a coordinate plane this probably lays at a slant. So we need a little more information. We're going to need a formula. So the formula we're going to need will look like this. This is what I call the skeleton of the distance formula. The distance will be equal to the values that you subtract and then square, and the numbers go in these yellow dots I've just placed on the screen. They will also, you will be inserting numbers here and here. Now what these numbers are exactly is you put your x's from your ordered pairs in here, and you put your y's right here, and you put them in the same order. These are x's, so there'll be 2 of them, and these are your y's, and you put them in from the ordered pairs that you have that come from the endpoints of the line segment, and make sure you put them in the same order, because subtraction is very unforgiving. You can't mess with this sign right here. You can go only one way. So what I want to do now is apply this to the line segment we just had. The line segment we just had looked like this. So we had point E, which was the ordered pair 5, 1. And we had point F. See, this is point E. This is point F. Point F was the ordered pair 9, 4. What I'm going to do is I'm going to drop those numbers into the formula exactly where we want to see them. So this 5 I'm going to put right here because it's the x value for E. So I'm going to put the 5 right here. Now remember, I'm choosing from E first. And then I'm going to take the x value from the F point and I'm going to put it right there. So this is my 9. Now I'm going to do exactly the same thing on the other side. So I'm going to take this 1, which is the y value from the E, and I'm going to drop it right here. Put the 1. And I'm going to take the y value from f, which is the 4, and put it right here. And once you drop your numbers in, it's just between you and your calculator and the order of operations as to how you get this right or not. You have to just work the problem. Okay, so let's see how this works. So we chose our x values from both ends of the line segment. We put in our y values from both ends of the line segment, and then this is what happens. 5 minus 9 is a negative 4, and of course that has to be squared. And a negative times a negative is a positive, and 4 times 4 is 16. If you don't believe me, use your calculator and type it in exactly like that. Plus, because the plus sign is still here, 1 minus 4 is a negative 3. And the negative 3 also has to be squared, so that's going to be a positive 9. And 16 plus 9 is 25, but remember, these are all still happening under that square root symbol. And of course, the square root of 25 is 5. So what we found is that the distance from E to F was 5. Last but not least, I want to show you how to use the Pythagorean theorem to calculate the distance of a line segment. You'll need to put the line segment on graph paper, the coordinate plane, just like you see in this picture. Now, the Pythagorean theorem is when you use a squared plus b squared equals c squared. C is your hypotenuse, and c, this c part right here, that's going to be the actual line segment that we're messing with. That's the length that we want to know. And we're going to use a vertical count and a horizontal count to represent the legs in this portion of this formula. And we're going to count off the graph. So if your line segment is on the graph, you simply do this. Use your imagination. And I want you to see a right triangle. That happens as I'm counting the spaces, going straight down from P, and I came down 1, 2, 3, 4 spaces. And from there, I'd have to go over 1, 2, 3, 4, 5, 6, 7, 8 to get to Q. So we are actually looking at a right triangle. Do you see it? This would be where the right angle is. So we're looking at a right triangle that has one leg of length 4 and a leg of length 8. And I simply did that by counting, like you did in Algebra 1 when you were messing with the slope or trying to calculate the slope of a line. And then I take these numbers and put them into the Pythagorean theorem. The 4 can be the A. The 8 is going to be the B part. And it'll look like this. 4 squared plus 8 squared equals C squared. And C is actually going to be the length of PQ. 4 squared is 16, 8 squared is 64. You add them up and you're going to get what? That's a 0, carry your 1, that's an 80. 80 equals the C squared. Let's drop down here and finish this out. We never solved for c squared, so what do we do to finish this out? You take the square root of both sides. So I'm going to take the square root of 80 and the square root of c squared. The square root of c squared is c, and the square root of 80 is going to be a decimal. And it's going to be an 8 point something. Use your calculator and calculate that and see what you get. You should have gotten an 8.9, and that's with some rounding. Now, go on to the examples videos and watch those before you go to the practice. Work on the distance formula and be careful with it. You have to make sure you're paying attention to exponents and to all of the subtraction that's going on.